Good afternoon, and welcome to the presentation of objects in description. It is an important specification developed by MPAI, and the scope of this specification, formerly called the Object and Scene Description MPI-OSD version 1.0, is to specify the formats to enable description and localization of unimodal and multimodal objects and scenes in a virtual space for uniform use across MPI technical specification. This is quite a unique case because it has been developed collectively by 4 groups by audio, human and machine conversation, portable avatar format, and connected autonomous vehicle. So we have this table here that shows the content of the standard. We have an introduction, we have the scope that I have just introduced, definitions, technical references, normative references. Then we have use cases, examples of use cases, and then we have the AI modules. AI module is the basic element that drives the development of many MPI standards. And finally, we have the data types whose format we specify. So let me start with describing some use cases. This one is conversation about the scene. So we have to imagine here that we have a human here, and the speech is captured, and here we capture the human, but also the environment of the human. And the environment of the human is made of objects. And so we have this visual scene description that describes the visual scene, because the audio scene is already is condensed in the input speech. And here we have the output of the visual scene are the descriptors of the body, the geometry of the scene, and the visual object in the scene. So this is passed through this visual object identification. We will get inside these AI modules later, whose result is instance ID. It says this is a hammer, or this is a plate, whatever. So here we have automatic speech recognition. So we have the machine has the text that has been uttered by the human, but we also have information about a particular object. Therefore, this information is used by this module here that is called natural language understanding, that produces the meaning and also refines the text if that was needed. This AI module here is quite interesting because it extracts, let me say, we call personal statement, which is a generalization of the notion of emotion. And this is also, so we have this AI module that extract the personal status. So personal status, meaning and refined text are the input of this entity dialogue processing that is in charge of providing the answer of the machine to this 3 data set. The output is the text and also the personal status, because the machine, in response to what has been said and to what it has captured from the visual information, is able to adapt its own personal status. And therefore, we have this personal status display that is another module that is able to generate all the information that is needed to synthesize an avatar, a speaking avatar, and also it has the ability to add to the speech and to the avatar the appropriate emotional information. Let's go to another one. So this one will be simpler because we have already introduced most of the elements. In this case, we have a human interacting with a connected autonomous vehicle. The vehicle captures the information from outside. The information is audio information. The audio can come from inside the car, or it can come from this subsystem that is in charge of capturing the information from the outside of the car. Same for the visual. So here we have the audio scene description and the visual scene description. So as you see, this is quite pertinent to what we are saying. What comes next is roughly comparable to what we have said. Also, we have the natural language understanding. We have the personal status extraction as before. Here we also have face object that is used to recognize the face of the human, because, you know, not everybody should come to my connected autonomous vehicle and use it. And same for the speech that is used to improve the recognition rate of the human. All this information here, which is, again, it is text, it is meaning. Here we also have the ID, because this dialogue processing entity will give a response based on the fact that the ID is the right one, because if it is not, then the dialogue processing entity will say something else. And again, it will produce the personal status of the machine and the text of the machine. Here we have other elements. One is this autonomous motion subsystem, and this is needed because this human-car interaction workflow understands, but then it needs to inform another subsystem about how it can properly implement the request made by the user. Autonomous motion subsystem, this is another example where we need the information, because we have this data type that is called environment representation fusion. This is an AI module, of course. And, you know, in fusing this environment representation, we have a lot of information that's spatial information, and therefore is represented with one of the specification in this standard. So this is the subsystem that I was mentioning before. So we have a lot of sensors, radar, LiDAR, we have visual, ultrasound, we have audio. So we have a lot of data types, and all these create a scene description. And the scene description is again implemented using the specification of this standard. Let me go to one that I have anticipated, that I would give a few more words. So the purpose of this visual spatial object identifier is to receive the body descriptors of the human. So the body descriptor, why? Because the human is pointing a finger to the object that it is asking the machine to recognize. So then, in order to be able to understand the direction, it needs the visual scene geometry. So it needs to know where the finger is and where the objects are. And so this AIM here is able to identify the direction and produces the direction that it is used by this to understand which object is actually meant. And finally, this AI module here will say, oh, you meant that one, and that is a hammer. This is another important composite AIM that is called audiovisual scene description. In our approach, we have the component that is the audio scene description, another component that is called input visual. They are integrated and we extract the information from geometry of the audio scene and the geometry of the visual scene. We identify which objects are collocated, and based on that, we say, oh, this is not an audio object or a separate visual object. No, this is an audio-visual object, and therefore we provide the geometry of the audio-visual scene based on which we can provide the full audio-visual scene description. So this is another important component. It's the audio scene description. This has not been developed by this group of experts, but it's been developed by the audio group, and so it applies sophisticated technologies. So this is the say the Fourier transform of the multi-channel audio that is input here, and the output is the audio-visual scene descriptors. So we have identified quite a few data types, and they are specified here. So let me take, for instance, the audio-visual scene descriptors. Or maybe let's start with something simpler, which is the visual scene geometry. So again, now I am taken to the website, and by the way, this is public, and so you will be able to access it yourself. So we have a definition of what the visual geometry is, visual scene geometry is, and this is the syntax. The syntax is a JSON syntax that is you can find on the website. And so let's see the semantics. The semantics is, okay, we have a header, and the header identifies which standard we are talking about. Then we have an ID. So we have a UUID by means of which you can identify any visual scene geometries. Then we have the representation of time. Then we have how many visual objects are there. So this is important information. And then here you are seeing that for each visual object, you have the visual object ID that will say, okay, what is the format of the visual object? And we have the spatial attitude. The spatial attitude is another important data type that is specified by this statement. So let me go back to my presentation. And so let's talk about the spatial attitude. Spatial attitude, again, the same story here. So the spatial attitude is a data type representing the position, orientation, velocities, and accelerations of an object. And so here you have the syntax. I'm not going to open again, but here you have the semantics. Same story. We have the header that tells you which standard it is. Then we have also a UUID used to identify this spatial attitude. Then we have some general information. So what kind of coordinates we use? What is the object that we are dealing with? And the object, at the moment, we have digital human, we have a generic object, and the other ones are reserved. Then what is the precision which will represent the position, the media types? We have audio, visual, haptic, smell, radar, lidar, ultrasound, and reserve. Of course, radar, lidar is because, and ultrasound is because we need them for the connected autonomous vehicle. And then we have, well, something that is needed in order to reduce the amount of information that is needed. And so here we have the position, orientation, velocity, and acceleration. So with that, let me move on. But I'm just underlying the fact that there is a richness of data type. Each of them, of course, has cost a significant amount of time to the expert to develop. What's the next? The next is to update the specification because this is version 1.0, by the way. But we needed to extend it. So we have already two examples. The first one is occlusion. So what happens? How do we describe two objects that maybe one is partially by another object in front of it, and the other one is is the extension to two dimensions. So I give you here a quick introduction. So this is a use case that we are currently developing. It will be a use case implemented on the AIF, which is this environment I've talked about, and then we have the AI workflow, which is this part. So we have 7 AI modules. Um, the purpose of this is that you have a video and you want to have a description of what is in this video. And the description is essentially, this is the purpose of this workflow, is to identify the scene changes for the purpose of identifying who are the persons there. And then we also have another one that is diarization, which means that there may be 3 people in the scene speaking, and we want to have the three flows. So we use the video frame and the speech to identify who are the speakers, and then we recognize the speech, and so we have as an output the face ID, the speaker ID, and the recognized text. So this is deliberately called audiovisual scene description, which is not something that at the moment we support, because at the moment what we have is targeted to a 3D context, but we want to be able to describe the, the screen of a television in terms of speakers and faces and so on, identities as part of the scene descriptors. So with that, we really are looking forward to working with you on this exciting Empire project, which has just started, but will continue. And my invitation is that you join Empire, share the fun, and build the future, which is our motto. Thank you very much for your attention.